Hi everyone. In this example, we're going to use a two-way frequency or contingency table consisting of counts, where it's not just 1, 1, 1, 1, like we had over here, 1, 1, 1, 1. All right, let's say that you're a tutor. You're a junior, and you like tutoring other juniors. And if a student's not a junior, you don't want to tutor the A students. You'd rather tutor B and C students. So let's say that you're considering the students in a class. All 26 students in the class are passing. They're all getting A's, B's, or C's right now, but they seek tutoring. Now, you, the tutor, you're a junior who likes helping students who are juniors or who are receiving a B or a C, regardless of class status. By the way, there are no freshmen in the class, only sophomores, juniors, and seniors. Based on the following two-way frequency or contingency table, find the probability. So we want the probability that a random student in the class is a junior or is getting a B or a C. In other words, the probability that a random student in the class is someone whom you'd be willing to help. Okay, all 26 students are accounted for here. I'm not trying to trick you. If you add up all these numbers in here, they add up to 26. Okay, let's go through each of these cells and ask, are these students whom you would be willing to tutor or not? Yes or no? All right. The sophomore getting an A, would you be willing to tutor this student? The answer is, sorry, no. What about sophomores getting Bs? In principle, you'd be willing to because they're getting Bs, but it doesn't matter so much in this case because there are none of them. In principle, though, let's circle the 0. What about sophomores getting Cs, these two people? Yes, they're getting Cs. You'd be willing to tutor them. Okay. What about all the juniors? You're willing to tutor all the juniors, the ones getting A's or B's or C's. What about the two seniors getting A's? No. They're not juniors, and they're not getting B's or C's. What about seniors getting B's? Yes, they're getting B's. What about seniors getting C's? Yes, these three you're willing to tutor. So how many students in the class would you be willing to tutor? You can add these up, and you would get 23. So the probability would be 23 over 26. Can you tell me a faster way you could have done this? And we're going to see this in other probability problems. What's the faster way you could have done this? Well, there are 26 students total. You are only willing, there are only 3 students whom you are not willing to tutor. Only 3 whom you would have said no to. And 26 minus 3 is 23. In a way where you're considering the complement first, the probability that you wouldn't tutor the student is 3 over 26. So the complement of that, which is what you want, is 23 over 26. Sometimes subtraction helps. All right, so once again, you're not willing to tutor the 3 students here indicated in red, but you're willing to tutor everyone else. 23 over 26, or about 0.885 or 88.5%. Now, and again, there was the subtraction method you could have used. An easy way of determining that the sum is 23, aside from just adding all of these. You could have gone either way, though. Now, here's the thing. What if you had worked out the marginals? And very often in a problem, you would work out the marginals. So someone might say, hey, I notice here that there are 14 juniors, there are 12 students getting B's, and there are 6 students getting C's. Add them up, 14 plus 12 plus 6, that's 32. 32 over 26. No. First of all, obviously wrong. Why? Because this is greater than 1, so there's no way it's even a probability. But beyond that, there's a problem here. What's the problem with just adding 14, 12, and 6 and putting that over 26, aside from this issue? Because if you do that, you're double counting. You're double counting these 9 students. Juniors getting B's or C's. You're double counting. That's my warning here. Don't double count. So that's the problem with just adding these marginal totals, because you're in severe danger of double counting. Now, what would work? You could take the 32. 14 plus 12 plus 6 is 32, but you have to recognize that you're double counting these 9 students in here. But if you subtract off the 9 students and then put it over 26, 32 minus 9 is 23, and you get 23 over 26, and that would work. So I'm not saying that these marginals here, these row and column totals, I'm not saying that these are useless, but if you use them, you better adjust. Adjust and make sure that you're not double counting or triple counting or whatever. Okay, so there may be more than one way of doing things. We've looked at straight up addition. We've looked at a subtraction method. And we've looked at using row and column totals, provided you adjust accordingly so that you don't double count, all right? Because if you fail to adjust for that, you're going to be doing a similar sin as if you triple counted this boxcars case over here, 6, 6. Make sure you don't double count or triple count. Count the appropriate students only once. All right, next up, when do we multiply probabilities? Those are AND problems. Next time.